Hello, and thank you for joining us today on Dynamo BIM. Today on this session of Python for Revit tools, we're going to be talking about Git. Ehsan is going to be talking about Git. He's been telling me that I need to learn it. So here we are. And this is what we're going to do today on this session. And hopefully not necessarily build a tool for Revit, but we're going to add a tool to our library of tools in order to code, to be coders. Right, Ehsan?
You will be able to work with your code a lot safer. So you have a full history of all the changes that you have made. You can go back in time whenever you need to. So you can track your changes. You can share your code with everybody else. They can contribute to your code. You can do the same to somebody else's code base. So it's sort of like a really amazing tool for collaboration on anything that's fairly text-based. So even if it's a Dynamo file, because it's just a JSON file basically with a different extension, and it's text-based, everybody else can still collaborate on it. If you look at the show notes, I'm going to officially call it the show notes for episode 2.
In the description.
In the description of this video. The first one is an application that I've linked in there. It's called Fork. It's just a suggestion. There is a link right under it that says like others. You can look at other GUI applications for Git, and I'll explain what exactly these are. But it's just basically graphical user interfaces that help us work with Git a lot easier. They can show us the history and the changes that I've made on every change and all that kind of stuff, and I'll take you through it. We're going to use Fork for this video. It's actually, I think you can use it for free for a while as a trial, but then it's a paid application. But there's plenty of like free alternatives out there and whatnot. I just like Git, like Fork so much that I just have that installed on my machine, and that's the one that I'll be using. But no matter what client you use, the concepts that we're going to talk about are exactly the same. They're not dependent on the actual GUI application that we're going to use. You can find and download another application, just search for these stuff, the basic commands that we use, and then you'll find them pretty much in exact same spot as the other one. They're all kind of look the same because they're built on these Git concepts. Okay, so let me actually start sharing my screen. Okay, so that is your Dynamo. That's your Git repo that you have, and we'll talk about it. I'm going to open a simple text file in my VS Code, and let's call it. Let's call it a Python. Let's make it a Python file. All right. Save it as a Python file under Downloads and say test, or like Git intro.py, not GTI, Git. Okay, so let's say we have created a function called like test, and all it does is that I'm going to make this one bigger, print hello world. Okay, let's say this is the source code that I have. Now, if I go and make some changes to this and save it, I'm overwriting my previous work, right? So in this case, it doesn't matter as much, but let's say this source code actually does something, but you want to make some changes to it to make it work the other way, just to explore and see how it gets. And then if it doesn't work that way, you want to be able to go back to the original version, right? So you kind of want to need a way to track your changes. Otherwise, you have to copy this whole source code of your project somewhere else. And it's not just going to, in most cases, it's not just going to be one single file. You have to copy the whole thing somewhere else, just like you back up Revit models before you make changes to it and whatnot. You have to copy the whole thing somewhere else and then make changes. And then if it doesn't work out, bring all of them back and all that kind of stuff, which is incredibly hard to do. So what we do is that we use an application that's called Git. If you search Git SCM on the World Wide Web, it'll take you to this website, git-scm. And this is sort of like the main website for the Git project. The Git was started many years ago by Linus Torvalds and Junio Hamano, which were both our co-developers on the Linux project. They actually started this as a source control, as a source manager for the Linux project. And it's still being used on that project, just to be able to get a lot of different developers and whatnot collaborate on the Linux kernel. The concepts are very simple, very easy. I'm going to go through the concepts first, and then we'll talk about the actual sort of like the application and how we can actually use to do these things. So there's also really good documentation and stuff like that in here too, just in case you want to know more about Git. I'm gonna add that one in here too. Git website would be here, just so you know. Okay, so let's say I want to make a change to this. Instead of saying hello world, I wanted to say hello Dana, right? When I make this change, if this source code is part of a Git repository, which is basically a collection of files, could be anything. It's not just source code. Git doesn't care. You can throw images, you can throw files, source codes, Dynamo scripts, Python. It doesn't care. As long as it can sort of like manage that file for you, it'll take care of that automatically. So if I make a change to this, and this file is part of a repository, that package that I'll show you how we can create, Git will notice that I've changed that line from hello world to hello Dana. And then I can commit that change to the repository. And I can say, okay, so the previous version was hello world. I made some changes to my source code to work differently. I'm going to commit these changes to the repository. So you've already saved it in your file, but because the file is part of a repo, we'll commit that change to the repository, and it officially becomes the part of the history. This is called the concept of committing. And after that, then your repository is sort of like in a closed state, and then you make some changes and you make other commits and you just go forward. It's kind of like when you're working with Revit file, it's kind of like a transaction. So you go make some changes in your Revit model, and or kind of like syncing in a central, right? So you go through a whole bunch of changes in your model and like, okay, I'm happy, everything works. Let's sync to central. It will save your file, and it would also upload it to the server. So conceptually, it's kind of similar. That's sort of like called committing. And then there's another concept that's called branching. Because we are going through the history and we are making changes, there's this underlying mechanism that we can also go into different branches. So if you have come to this point, we can branch out, go make some changes somewhere else, and then come back to the original branch and sort of like explore options in a different safe space. And if they don't work, we can always revert them and switch back to the original branch. So just know, the only thing that you want to take from it is that branching is possible. Like this is something that we don't have in Revit, or the way we have it is kind of like design options. Design options give you different branches. So in the same space, you can explore multiple different options, right? Okay. Kind of similar to that. And then there's this concept of pulling and pushing. So if the Git repository is somewhere on the cloud, when other people go and make changes to the code, we on our side will pull the changes to our clone of the repository. The copy that we have on our machine, it looks to the server and pull those. It's kind of like synchronizing, but one way, right? So it just downloads the changes from that other people have applied to the source code to our machine. Pushing is the other way. So push is kind of like synchronize. So you get all the changes, and then whatever the changes that you have made that other people don't have, you'll push them to the repository, and it will upload those changes to the GitHub repo, and then everybody else can pull and get those changes from you, right? Okay, so let's go. So these are the stuff just want to get you a little bit of like idea of like what we're dealing with here. We'll go through setting up a Git repository and sort of like working through it. Now, Git is a command line utility. So let me actually pull this one out. So if you have the terminal in your application, like if you have Mac OS, Git already is installed on your machine. But if you don't, you can install that as an installer from that website that I gave you on Windows, so you can have access to the command line. When you say Git, that's the Git. It'll spit out the help for the Git command. But because it's a sort of like a fairly complex thing to deal with, we generally don't want to deal with it on the command line. And that's why we use a GUI application fork that I told you about to sort of like make life a little bit simpler and be able to work with it interactively. What an application like Fork does is that it basically runs that command, the CLI command in the background, with the right options and command lines and configurations and all that kind of stuff to do the things that we told it to do in the GUI application, in the graphical user interface. What I'm going to give you, it's sort of like a little bit of overview of Git is the Pyruvate repository. So right now inside fork, and I'm going to minimize this a little so it's not too overwhelming. I'm going to close a bunch of these so it's not too crazy looking. We have when you open a Git repository inside a GUI application like this, you will see a list of commits in your history. So every one of these circles here, it's one change that I've made to that repo. Now, one change could be many changes to many files. It's just that we combine those as one action in one commit. Like, for example, in that
it also
commit,
be like the addition of files, right? It doesn't necessarily mean a change to a file. It just
means exactly. That's a great thing.
In general.
Yeah. Great question. It could be deletion of a file, addition of a file, modification of files. Any of these could be part of that change, right? So like in this one, I have fixed the issue number 1198, and that's the comment that I've put on that commit that explains what that commit was. Part of that commit, if you look at the panel down here, you'll see that's the person that made that change. There's sort of like a verification of like that person, they sort of like that's the real person that does this. This SHA is the unique ID of that commit, and it's unique across the full history of this repository. And then that's the title. And then this is the list of changes that have been as part of this commit. So we have seen that this icon, this yellow icon, means that that file has been modified. So if I click on that, it actually takes me to that line and say the previous line 50 deleted, new line 50 is this green one. So this red is always deletion, green is always addition, right? And Git shows them sometimes as minus means deleting and plus means adding. Now, Git works line by line. So it doesn't track exactly what character that it changed inside the line. Because I changed the value in here, it says, you can see there's like darker red in here. It says that's why you changed, but it deletes that whole line and then replaces it with a new line, right? So its smallest unit that it can track is a single line. Does that make sense?
Mm-hmm.
So that's why you see like the red and green, although we made a little change in here, like I added the is set here and I put the false in the value. Those are the only things that are different. And you can see that this is darker green and darker red. That's the real change that I made. But because of the Git subsystem, the previous line is deleted, new line is added. And you can see the line numbers, the previous set of line numbers and the new set of line numbers shown that way. And then on the next file, we can see the same thing. Like here, that 56 was deleted, new 56 was added, and then there's a new 57. This 57 wasn't existing before. So that's a whole new line that was added. And you can just go down through the file and see, and it doesn't show you the whole file. Like you can see the line numbers, it skips the one that hasn't changed, right? And usually this is the one that you can configure in the application and say, hey, I want to see the whole file or not. It doesn't matter. That's just graphics of like how it'll show you changes. And then let me actually go through another commit that has like file deletions maybe. Let me go through. This is all file changes. Oh, okay. So see, this one is 2 pluses, the green. That means that file has been added. So this is where I added a new script to my Git repository. And then sometimes there is a deletion too. That's all modification. Oh, so like this one is a move. It tracked that I moved one file from another to another place. And this one is the icon for deletion. Right? So that file has been removed from this repo as part of that commit. So you can see that it's the history of changes that we made. Every one of these commits is one change action. It could include many changes to files, removing, adding, and all that kind of stuff as part of one commit. And as you go down, you go back in time. So if I scroll this back, all the way back there, you can see the first commit that I made to that project was on August 16, 2015. That's the first commit of the Pyruvate project. So I can reset this repository back to that point and look at all the source code that I made at that time without in a single repo. I don't have million different copies of Pyruvate everywhere, right? But because we have used this to track the changes, I can right click on any of these and take the repo back to that time. Maybe I wanted a file that I had back there that I deleted later, or like a piece of source code that I had that I wanted to see. Or somebody else, like for example, maybe like you went through version 1 and then you made changes to version 2 and published those, but then somebody doesn't want the version 2, they still want the version 1. They can go back through the repo to version 1 and use the version 1. So it gives you a full sort of like history of your project. Imagine if Revit worked this way. It would be freaking amazing. That you would have like all the history, that if you saw somebody like deleting something, you could have reverted your model back very easily, or that specific piece of it. So that's sort of like the timeline that we're going to talk about. That's the branch and its history. The way that's generally shown on most applications is that the one, the commit that you see on top, is the most recent one, and then as you go back in time, it goes sort of like back through time. And then you see stuff like this. That's the concept of branching that I talked about. So like when we were here, I branched out, made some other changes, tested them, and when they were ready and I was happy with them, I merged them back to the original branch. And we'll talk about these branching sort of like in more detail. But just, when you see stuff like this, it's just we are branching and merging, or we are branching and merging. Sometimes we branch and we don't merge. We're like, yeah, that change didn't work out. We just leave it there, and it will remain as part of the history, but it's now not going to be part of the part of the main project. And sort of like that's the standard way of this graphical applications showing you multiple different branches. They try to like each one of them takes a color and sort of like easier to track it. And you're like, okay, so that's the branch. And on part of the blue, like not much changes has been made. Green the same. Red has a whole bunch of them here. So it could get really confusing when you're looking at big repositories. Like for example, in Rhino source code, I can't really understand what's going on because there's a lot of automating stuff happening in the background that does all the changes and whatnot to the repo. So it could get fairly confusing on really large software projects, but still. Okay, imagine if I have the full Git repository on my machine, I won't be able to share it with anybody else because just they don't have access to my machine. So we use that cloud thing so I can push the Git repository to somewhere in GitHub. Maybe you want to use GitLab, maybe Bitbucket, which is a product from another company, and sort of like use it that way. But all of these are different services. GitHub is one of the most famous ones. Exactly. You went through there and click on that plus button. She's creating a Git repository under her account. She's the owner. The name of that Git repo is Python for Revit. That green check mark tells Dana that name is unique. Nobody else has a repository with that name. She's putting a description for that repository. So me as a user, when I find this on GitHub, I know what this is about, or at least I can see if this is what I'm looking for or not. They might not know what Revit is and whatnot, but they can see that this is sort of like part of the something else. She can choose to make it public or private. Some cloud services will ask you to pay to have private repositories. GitHub used to be like this. When Microsoft bought it, they made a whole bunch of you can create a series of free ones, I think. You get to, hold on, before you click, you get to sort of like decide to add a README to the or a license to your repo. Generally choose a license too, and you can to make it sort of like freely available, just use the MIT license. Just type MIT there. Yeah, MIT license. So it'll add 2 files to your repository before we even do anything. It'll add a README and a license file, right? So it initializes your repository with 2 text files in it already. Cool. So hit create repository, and that would create the repository on her account. And if you scroll down, yeah, you'll see the second one. Exactly. You can go there. And then there's a green line in front of it. Like as you make changes or other make changes to the repository, you can actually see like the sort of like the heartbeat of that repo and like how much activity is happening on it. So this is the standard way that Git will show you the content of the repository. Where your sort of like little avatar is, that's the contents. You can see there's a license file and a README file. And it will render the README right under it. So sort of like when you walk into the repo, the README is shown right under the repo, so you don't have to click on it again, right? That's the content of README, and it says readme.md. And MD is markdown. We'll talk about that a little. And then on the right side, you see there's releases when we create releases and packages and stuff like that. We don't have to worry about those sort of like at all. And you can see that right in front of your avatar. If you sort of like look at the right side of that blue bar, you see it says 1 commit. And if you click on that, it'll show you the history of that repo. The first commit is on March 20th, 2021. Its name is initial commit, the name of that commit that we made. We could have made that anything, but it's automatically names it initial commit. And there's nothing else before this. That's the full history of the repo, right? Okay. So you have the repo ready. Now, you want to share that with me so I can work with that repo as well. Go back to the homepage of your repo. So click on its name. You can just click on the name of that repo. Yeah, that's fine. Go on. And then, click on that code thing, the green code. And then see there's a weird like HTTPS link right there. Send that one to me. That's the unique URL for this Git repository. So send that one to me. And if you don't mind stopping your screen, I can start sharing and show you like how I can work with this repository as another developer, let's say. Okay. So now if I go under Dynamo Bim's account, her account, I can see that there's a new one in here, and I can see that one in here as well. She already sent me the code, what's his name? The URL for this, but I can see all of this in here too, so I can copy that right here as well. Okay, let's talk about cloning. I'm going to copy this URL, and I'm going to go to fork, and I'm going to say I need to clone from the file menu. I need to clone a repository, and it tells me, give me that URL. It already looks at my clipboard, pastes what I have in my clipboard right inside that box. So it already has it. I don't have to do anything. And it tells me, okay, so where do you want to clone it? This is effectively creating a copy of that cloud-based repository on GitHub onto my local machine. So I'm going to say, let's do it on downloads directory. And the name of it would be Python for Revit, the default, or I can change it. I can say Py for Revit, something else, right? It's the same thing, or it doesn't matter. Git doesn't care what the name of your clone is. And that's pretty much it. We hit clone, and fork will clone that repository. It'll open a new tab for me. I can close the Revit tab. One of the nice things about fork is that you can actually work with many different repositories at the same time in different tabs. So I'm just going to close that tab. The name of that repo is here. That's the repo that we're working on. That's the name of, not the name of the original repo, it's the name of the clone that we have on our own machine, right? And I can see the exact same thing. Initial commit, Dana made it, the time and all that kind of stuff, identical, exactly the same. I have a full copy of that repo right here. Okay, we have created effectively a Git repository, and she created it and shared it with me, so I cloned it, and I can make some changes to this. Let's go and make some changes to that. If I go to download folder, I can see that there's that directory here and the two files right here, right? In Visual Studio Code, because I want to work with this, I'm going to go to the panel and say open folder and open that directory. So in my browser, now I can see the files that are added. And Visual Studio Code also has a Git utility inside itself. So you can see on the bottom of the screen, it'll tell me you're on the main branch. And I can still use the utilities inside Visual Studio to be able to make changes and all that kind of stuff too. So you don't technically need a application like Fork, but Fork visualizes this stuff a lot better. You can work with multiple repositories at the same time. You don't have to have a code editor open, so you can just pull changes and review changes from somebody else, that kind of stuff. So it's a little bit more advanced. And Visual Studio Code also recognizes some of the files. Like it knows this is a license file because its name is license. So it shows you a different icon. It knows this is a markdown, so it shows you a markdown icon. Markdown is a way of writing formatted code without it, formatted text without it actually being formatted. So there's conventions, and you can look them up. Just say like markdown help, and it will give you the help about like how to write markdown. But basically, if you put one of these pounds in front of the line, it turns it into a header, right? So if I go to the thing, that's why this has been rendered as bold. It's because there's a pound in front of the that text inside the text file. So it's sort of like a little language in the way that you write text to tell the renderer how do you want to render these stuff, instead of using Word and that more complex, rich text formats. You just use a standard text file just with characters. You'll tell it what it wants to do. Um, we'll talk about this stuff later in future videos. It's not necessary. You don't have to use this with Git. You can use any other format if you want to. Anyway, so these two files are here. We want to add the files that I want to add the files that from previous session to this one. So I'm going to create a new folder, call it session1. And inside that folder, I'm going to go grab the session1 contents. I'm going to copy that Python stuff. What did we name that file? What was it? Create worksets. Let's create a new file. Huh?
Workset default visibility is what I called it.
Okay, workset default visibility.py. I'm going to create a file, empty, content here, save. Don't need it anymore. And what is this one? Let's call this one also, this is Dynamo template, right? So let's create another one, Dynamo Python template.py. Save that one here too. So I added two files and a directory to the Git repo. Now, I haven't done anything other than creating these files and saving the contents. I'm going to go back to fork. Fork automatically, as it's working in the background, automatically is looking at the changes in your repo. If you go to the right side and look at the local changes, it tells you there are two changes. And you can see there's directory session1. These two files have been added. It doesn't care about the creation of directories because that's inherent in creation of that file, right? So when that file has been created, the path to that file includes that new directory, right? So it doesn't tell you that, hey, you created a session1 directory. If it's empty, it doesn't even look at those directories because they don't matter. There's nothing in it. So we can see that these two files have been added. It'll show the contents, and it basically marks everything with green because they're all new lines, right? Does that make sense?
Yeah.
Okay.
All new, all green.
Yeah, all green. That's the new file, and the icon also shows us that it's a new file. Now, what we see here, this terminology is very important. What we what we see here, the files that we're seeing in here, it's sort of like our working directory. This is the place that we work with the files and all that kind of stuff. Git, the information of the Git repo is actually stored in a hidden directory. I just marked my finder to show the hidden files. That's called the .git. The reason that it starts with dot is because it's a Unix convention. Any file name or directory that's name starts with dot is by default hidden. And it stores all its information inside this directory. Never make changes to this directory manually. That's the information. That's sort of like the stuff that Revit stores in those weird directories. Whenever you open a Revit model, you don't want to mess with those. Those are the stuff that Git knows and Git organizes, and it's incredibly important in the way they're organized, and because otherwise you're corrupt your repo. So you don't want to ever write anything inside that repository or make any changes to it. This is called a working tree. This is a place that Git places this stuff, the stuff that are part of that repo, so we can work with them, right? So if I go back to previous history of a repository, Git will replace these contents with the old contents of the previous stuff, and I'll show you how it works. But the reality is that when we commit the changes, all the stuff that we commit are actually hashed and packed in special files inside that .git directory. So the package is really that .git. That's the Git repo that we're talking about. This is the files that we're working with, so we can communicate with Git and say, okay, I made changes to this, add this stuff to the repo, or like I want an old version, give all the older versions to me. We don't get into too much detail about it, but we just noticed that there's another file added here. The operating system, Windows does this too with like thumb.db files, looked at this directory, generated a whole bunch of stuff about it, and wrote it in an hidden file called ds_store, which is sort of like for Finder to store some of the settings. Just the fact that I opened this and left it like this created that stuff. So sometimes the operating system or like other application that you're working with inside your repo will add content to that directory, and Git will notice those. Most of the times we don't want this stuff. That's part of the reason that we add a git ignore file to the repo. Don't worry about it. Just know that that's there, and we'll sort of like talk about this in future sessions. But I don't want to add that to my repo because it's not part of my content, right? If you copy this, if you clone this repo on Windows, then that file would be different. We don't really care about that. So I'm going to add these two and stage them. Stage them takes the changes that I made, puts it in a different place in Git that's called a stage that is ready for committing. So I might have more changes in here. Like I can see the DS story is there, but I'm not going to commit that. I'm going to add the changes that I made to the staging area. And then at the bottom of this window, I'm going to write my commit message, added session 1 contents. And I'm going to commit these two files that are inside the staging to the repo. They get committed. They're not part of the local changes anymore because it's already been committed. If I go back to here to the branches, we always get the main branch or master branch, one of these two, when you start a repo. That's where everything is. From here, you can branch out and sort of like merge back in later on. But you can see that the initial commit was here. We have one commit right after that. That's what I made, right? You can see in front of this commit, there's a red thing that says main. That's the branch on my local machine. And there's a green one on the previous commit that says origin.main. If we look at the remotes in here, we can see there's an origin, and that has a main too. That's the cloud that's sitting on Git repo, right? It tells me that the cloud is here, you are here. Means that I have one extra commit that I've made that other people on the cloud, they don't have, right? And that's what this one with an arrow to the top means, what that means. It means that you're one commit ahead of the branch of the origin, right? And sometimes they're a mix of them. Like it could say like you're 3 behind and 1 ahead, stuff like this. We could get, so don't sort of like freak out if you see stuff like that. I'm going to push this change to the repo. The problem is that because you own the repo, I don't have access to it. So you need to add me as a collaborator to that repo. I'm going to stop, and you can start sharing again. And sort of like go to the GitHub repo and add me as a collaborator.
Okay, so we're going to manage access.
Beautiful. Okay. So invite a collaborator.
Invite a collaborator. Great. Okay, yes.
Oh, yeah. Okay. There we go. That's me right there. Just click on the, okay. Add Ranjai to the repo. Okay. I'm going to switch back to my screen again. Oh, yeah. So, yeah, your pending invite and all that kind of stuff. I'll show you my screen so you see that I get a notification from you. So if I refresh, yeah, I think this one it is. If I click on the notification in the corner, it says, hey, Dynamo BIM invited you to that repo. Do you want to accept? I say yes. Now I'm part of that project too. So both of us have write access to this repo now. So I can go to my fork and say push from here. This button right there. I can say push, and it will tell me where do you want to push this. I want to say to the main branch of the origin. Right? The default. Origin is generally the default. And then don't worry about this stuff. And I'm going to say push. See that it'll push, and that one will go away. And both of these green and red things are on the same commit now. So it says you're on the same that commit, and the origin main is also on that same commit. So origin has my changes now, right? So if I go back to the repo, whether we would see one commit, if you refresh, we'll see 2 commits. And then my sort of like avatar is the last one. The last person that made that change will show up there. If I click on this, I'll see that the full history, you added something, I added something, the unique ID of both of these commits are here. You can click on this and you can share that link and point somebody directly to that change. If you click on that change, for example, this one, you can actually, GitHub will render all those changes for you too. So you can see new file, all green content, new file, all green content right here. Exact same sort of like visualization. All these Git applications, we use the same. Nobody shows changes with different color, red, green. And then in this one, if you click on that, we'll see that, hey, 2 new files, new file, all the new content, another file, all the new content. That's been added in these two changes. Now, let's say I want to go back in time to this one and see what happens. Now, if I look at my Visual Studio Code right here, I can see that session is there, the files are there, I can open them, everything works, right? I'm going to click on any of this commit. You can go back in history, right? We just have two, so I'm going to click on the second one and say reset main to here, and I'm going to say hard. It's going to be a hard reset, meaning discard all the local changes. Anything that I have made change currently in my repo, get rid of them. Reset. So now main is here. The origin main is in a different place, right? So we went back in time. When did these changes have been made? Into the directory that was our working tree. So that's session 1 with the 2 files. They're not there anymore. If I go back here, they're not there anymore. Git took them away. Why? Because it's tracking the changes, so it can always undo. Right? So it removed those files. Everything's back to normal. The repo is identical to the time at that commit. Again, the directory working tree. Now I can see my main is 1 behind the origin. That's why the arrow is pointing down. Is that you're 1 commit behind. So normally when you're working on a project or you haven't touched the project and then other people have pushed like 20 commits up there, when you open your repo in Fork, it'll tell you you're 20 behind, and then you pull the changes. So now I can go click on the pull button, and let's say this is where I was when I cloned the project, and this other person added that commit that I don't have right now. I'm going to click on commit. I'm going to click on pull, and it's going to tell me where do you want to pull from. Origin is our remote, branch is main, and I'm going to say pull. And it would pull that change into my repo, and it would correct the working tree. So now that session is here, the files are here, everything looks exactly the way that I sort of like made changes to that commit. Everything is there. I'm nor behind or ahead. Everything works, right? So all the branches that you see here on the branches, these are on the ones that are on your local repo, and all the origins that you see, this is on sort of like clouds. Now, we could get very complex. You can have repos that have multiple different cloud origins. So you could push your changes to a public repo, and then maybe you have another backup one that you sometimes push to that one too. So we can do that as well. That's why when you say push, it'll ask you where do you want to push. But generally, the defaults are fine. We don't have to worry about this that much. One other thing that we can do with Git repos is that we can tag a specific commit that I'll show you at the end of this discussion. So tell me if any of the stuff that we talked about right now made sense to you, and if you have any questions.
I mean, I just don't know that this is going to be the way that I'm going to use Git, but I definitely, like, for example, would like to know how to get other people's information from Git, like yours, like getting Revit stuff from Git,
Okay.
or getting the Aussie BIM gurus stuff from Git, or John Pearson's stuff from Git, like seeing what they have up there.
Okay. Yeah, you could do that too, just like the way that I showed you that you can copy this file and clone the repo and have the repo on your machine. Nobody will take it away from you. You have the source code on your machine, so you can look into the files. You can do whatever you want. You don't have to make changes to them. Or if you make changes to them, you can always go to the fork and say, discard all these changes that I made and go back to the original, right? You can always do that. But in this example, we added sort of like scripts, right? Python scripts. They don't have to be this. Like, for example, I'm going to go back to this original stuff and download this Dynamo file that you had. I'm going to download that. And I'm going to add that to the first session as well, right? And if I go here to my fork and look at the local changes, you'll see that file and its contents too, because it's just a text file, right? So you can track all the changes that's been made to it. I can add that one here and say added Dynamo example as well. And push, and it will go to the repo, and I'm done. I'm nor behind, nor I added one more commit to this. We are all on the same, my local and the the cloud is on the same thing. I just push that change. If you go back to the repo and refresh and go to the session directory, that file is here. So you can actually click on this and you can share this file with somebody else. Git's actually a really good place to share files too. Like, for example, I'm going to go under my account and look at repositories, look at Revit sheet, like Revit cheat sheets. That's a repo that I made with a bunch of PDF files inside it. right? And I shared it with other people. They can clone and use these PDF files. What's nice about Git is that it makes makes the history trackable, right? So if somebody wants to make some upgrades and modifications to this workset creation, they can actually make that change and submit that PR to you, which is going to be the last thing that we're going to talk about in this session under Git. So it provides a method for other people to collaborate and improve your content and all that kind of stuff, and source code, and maybe get rid of the bugs and all that kind of stuff for you. Does that make sense?
Totally.
Okay. And then locally, even if you don't want to share it for other people, with other people, one of the reasons that I always do is that is always create a Git repo for my source code projects that I'm working on, is that it'll give you full access to your history. There's going to be a lot of times that you're like, oh my God, I made that change to that Dynamo script, but I didn't save it. So I don't have that anymore. But if you have that as part of a repo, you can always reset your branch, go grab that file at that time, and then come back, pull the changes again, and sort of like add it to your, or make modifications to it and all that kind of stuff. So it's a great way to keep history. Now, the last thing that we want to talk about is we'll actually go through this stuff to see. So we talked about what repo is. We talked about what a clone is. It's just a copy of that repository on your machine. We will talk about what's fork. We talk about fetch doesn't matter. Fetch is just checking whether there are changes on the repo or not. Fetch comes before the pull. So it checks to see if it's anything available, and then you say, yeah, pull them. But most of these applications, these GUI applications, they do an automatic fetch in the background so they can update the UI and say, hey, like somebody else added that button and stuff. So we don't really need to worry about the fetch. We know about the pull. We'll talk about branching. We know what commit is. Merging is related to branching. And then we pushed the changes to the repo as well. And we also reset it to a different time. Now, let's talk about branching really quick. Let's say I want to go back to this place in time. I'm going to reset the repo here where the file wasn't there. And I want to branch out of here. I'm going to create a new branch and call it develop. Like let's call it a feature. Let's call it I don't know. What about the work that we want to do, like test, right? Test branching. Jesus, I can't type. So I create a branch in here. You see there's a new red one added here that says you are on that branch, and there's that branch, the new branch that we just created is here. Now, if I go make any changes to the files now, let's say I want to go delete all of these, right? All of that stuff. And then go and commit that change. I see that the contents of that file has been deleted. I'm going to commit that change, call it delete one, commit that. And if I look at my my history again, I can see that the initial commit was this, and then main. The origin and main is there, and our branch that we branched from here, the next commit is right here, and it sorts them by time, right? And the reason that it swapped them is because this test branch is the active one, is the one that we're working on right now. So the orange line sort of like is the first line that it draws, and it shows you that main is somewhere else. It's sitting on a different branch, right? So I can keep working in this branch without affecting anybody else's work, test all the source code, make sure it's bug free, all that kind of stuff. Let's say I want to delete that one here too. Go to this file, delete that one too. Do some other changes and whatnot. I'm going to go commit that change here too. Say delete two, and go back to the repo. I can see that after this is this one. And now I can switch back to the main branch, and I can say merge into main and see what happens. See the changes that we made? Yeah, the changes that we made. Don't look at this red one because that's where the cloud is. The changes that we made, this delete and delete two, got merged back into the main. And then because the main is the active one right now, the orange represents the main. So we can see that the branched out in yellow, add two changes, and then branched and merged back again. Now I can push this change to the repo, and it would update, and those files, the contents of those files are going to be gone and all that kind of stuff. I'm not going to do it because it'll delete the contents. But just know that this is how branching works. If you're not going to use Git in more advanced, situations, you don't have to worry about this stuff. Because I didn't push these changes to the cloud repo, if I reset my repo back in here, I'll lose all those changes, right? Because I added them to my Git repo, but I haven't pushed these changes anywhere else. So when I say hard reset, all of them will go away, and that branch is sort of like is the branch that we created. The merge will go away. I can just delete that branch too. Let's delete that one, and we are all where we are before. So I just made some destructive changes to the repo, but because I had history, I went back through the history and just reset everything back to normal without worrying about stuff. So this is what makes Git super, super powerful.
Well, thank you so much, Ehsan.
Of course. Did you like it? Did it make sense?
Yeah.
Okay.